My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. Hello, you are welcome to episode number 61 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at the characteristics of sound waves. Remember, from the beginning of waves, I was able to establish that waves are disturbances that travel through medium or space, and they transfer energy from one place to another without mass transfer. Now, waves can travel through a medium or space. Space means they can travel without medium. Now, the types of waves that require material medium are referred to as mechanical waves. And sound is a mechanical wave. It requires material medium. You cannot pass sound through an empty space or vacuum. You won't hear. So, sound can travel in liquid, it can travel in solids, it can travel in gases. And based on the direction of propagation and the direction of the waves, waves can be transverse or longitudinal. Sound wave belong to this transverse, belong to the longitudinal family. The direction of propagation is parallel. The direction of production is parallel to the direction of the wave. Example, hey. You see, the wave is produced this way and the particles are moving like this. The top characteristics of sound waves are they have amplitude, wavelength, period, frequency, and speed or velocity. In one of the old episodes, we did calculations under all this and I did explain them. But it is necessary for me to say a few things about them. If this is a wave, you see this is a waveform like this. Now look at something. You see that this wave starts from, let's call here 0. It goes up like this, comes down. Now, this is where it started and this is the maximum displacement. So the maximum displacement from the mean position or from the starting position is amplitude. So the peak of the wave is amplitude. Now you look at something. It goes here like this, it comes down, repeats like this again. You will see that if we combine here and here, it forms a circle. So the time it takes for one complete circle from here to here is one circle. From here to here is 2 circles. So this wave has 2 circles. The time it will take for one complete circle is referred to as period. T. Period. And the number of cycle of wave per second is referred to as frequency. F. Look at this. The time it takes to complete one circle or for the wave to complete one circle is period. Now, the number of circles in 1 second, which is number of circles over time, that is frequency. While time over number of circles is period. So, frequency and period are inverse. Frequency is 1 over period and period is 1 over frequency. Wavelength is the minimum distance with which the wave repeats itself. Now look at something. If you see something like this here, like this, now you notice that something like this also repeats here, like this. Now if you look at something like this, you will see that this guy, something like this also repeats here. If you see something like this, you will see that it also repeats here. So the minimum distance in which a wave repeats itself is wavelength. So here and here are similar. From here to here is one wavelength, lambda. From here to here is another wavelength, lambda. From here to here is another wavelength, lambda. These are characters of wave. While we have speed, velocity, which is distance over time. Now, still on characteristics of sound waves, you remember that waves or sound can be musical or noise. Sound can produce musical notes or noise. And when it comes to sound, there are characters like the pitch of the sound, the quality of the sound, and the loudness of the sound. When it comes to sound waves, frequency is very, very important. The combination of sounds of definite or regular frequency is referred to as musical notes. Musical notes. Now, if you have sounds with irregular frequency, or the frequencies are not the same, no definite frequency, no regular frequency, it is referred to as noise. And noise is also referred to as unwanted sound. So, for you to have a sound that is wanted, like you play music, you see, it's comfortable to the ear. So this is because they have regular, definite frequency. That is what makes up musical notes. Combination of sounds with definite frequency or with regular frequencies. Now, musical notes is characterized by quality, pitch, and loudness. Loudness is also referred to as intensity of sound. So, anytime you hear music, under music, we have pitch, then we have the quality of music, then we have loudness or intensity. Now, pitch is the position of sound on a musical scale. If you have music, you are talking, you see the sound going up and down. The position of your sound in that musical scale is referred to as pitch. And pitch depends on frequency. And it is pitch that differentiates sound from young people and old people. Sound of annoyance or encouragement. All these are under pitch. While quality is the nature of sounds on the basis of their source. Nature of sound based on their source. When you look at a sound, you know that, okay, this sound is from a single tone, or this sound, it has multiple frequency, or it has multiple harmonics, or this is a sound from the well, this is a sound from the tap. So, trying to get or predict sound based on the nature of their source is referred to as quality. You know that this sound is from well, this sound is glass, this sound is from this particular instrument. That is quality. And for you to know the various ways sound come or to differentiate sounds, you must understand harmonics and overtone. Remember, harmonics and overtones especially, they are combination of various fundamental frequency. So, quality of sound does not just depend on frequency like pitch, but it depends on the harmonics and overtone. Quality depends on harmonics and overtone. And quality is one of the biggest property of sound. It is how we measure sound. We measure sound based on the quality of that sound. Now, loudness or intensity depends on amplitude. It tells us how intense or how high the sound is. So what determines the loudness of a sound is amplitude. So Jamb will ask you, pitch depends on dash, frequency. Quality depends on harmonic and overtone. While loudness, which is also the same thing as intensity, depends on amplitude. Intensity is the time rate of flow of energy per unit area and is perpendicular to the direction of the wave. So although we'll be using it or using loudness and intensity interchangeably, they actually refer to different things. Now look at this. Loudness is human perception of sound. Loud intensity or loudness is proportional to intensity, which means as the loudness of sound increases, the intensity increases, although it is not really a linear relationship. Now, loudness depends on intensity, and loudness also depends on the sensitivity of the ear. What may be very loud to me may not be so loud to someone else. This is because our ears have different sensitivity. The more sensitive your ear is, the louder the sound will feel for you. Ladies and gentlemen, this brings us to the end of this episode. Characteristics of sound waves. And I will be happy to see you in the next episode. Please get the Flashlearners Jamb application. Visit flashlearners.com to install one for yourself and activate the app to begin to play with questions. If you have issues, feel free to reach out to me on my social handles. I am Flash Isaac, or directly via chat. My number is shown on the screen. So, to pass Jamb, you need to follow the series and the Flashlearners Jamb application. Many persons who already did, they scored very high, 300 plus, 270 plus, and so on. It is your turn to do well. No games. See you in episode number 62, where we shall be talking about something else about sound waves.